Today we're going to talk about radical expressions. We're going to talk about simplifying radical expressions, and we're going to add and subtract rational expressions. Before we start, I drew a great big cube root of 8 here, and we're going to talk about what the different parts of a radical are, so that when I talk about it later, you'll know what I'm discussing. This little 3, the cube root of 8, this little 3 is called the index of the radical. This number will always show unless it's a 2. The 2 is for square root, and then it's understood if it's a 2. But if it's a 3, a 4, a 5, then you'll know what that is. That's called your index. The number underneath the radical, in this case 8, is the radicand. So the number underneath is the radicand. So radicand, index. Index, radicand, just so you know. All right, we're going to talk about simplifying first. And to simplify the radicals, to simplify a radical expression, factor the radicand, which is the number underneath the radical. Find the greatest number that occurs the number of times indicated by the index. Okay, copy that down. And you'll say, I don't really know what that means. So I gave 2 examples here so you know what I'm talking about. Then you'll say, oh, I remember doing that. I have right here the square root of 4. How do I know it's a square root of 24? Is because there's a 2 there that I can't see. It's understood. So I have the square root of 24. The first thing you want to do is factor it. Now you guys are all familiar with drawing your little tree diagram, or you can use your calculator to do the factoring. But I did 2 times 12, and then I broke the 12 down as 4 times 3, and the 4 down as 2 times 2. Okay? So now I want to simplify this. Well, in order to simplify this, what you have to do is group out the number of factors that match the number on the outside, your index. So I have a 2, so I got to see how many groups of 2 I can take out of there. So I have a group of 2 here, and that's it. So that group of 2 can come out of the radical as a 2, and whatever's left over, I have a 3 left over and a 2, that's 2 times 3 is 6, so that's 2 radicals 6. Another way you can write that, and what you'll be seeing too, is if you use the factor button on your calculator, your factor button will say this, 2 cubed times 3. That's what it'll show. Because 2 times 2 times 2 is 8, 8 times 3 is 24. So this is the same way as writing 24. And you'll notice I have 3 2's. So if I take 2 of them out, which is 1, 2, there's 1, 2 left inside and a 3, and that's 6. So either way will work if you factor it on your calculator or if you do your little diagram here. Now, to show you how this is demonstrated, I also put the cube root of 24. Well, I didn't show all the factoring again because we know that this is 2 cubed times 3. We just already talked about that. But if I'm doing the cube root of 24, well then you'll know I have to take out a group of 3. So if this group of 3 comes out as a 2, now I have 2 cube roots of 3. So if I take the cube root, I get this. If I take the square root, I get this. All depends on what your index is that we're talking about with the number. All right, let's practice some more. I have 3 more on this board, and to save a little bit of time, and because I know that you're familiar with this, and some of you will be using it definitely on your calculator, is I already went through and factored each one of these. So here I have the square root of 150. There's nothing there, so I assume it's a 2. So I factored it. I got 5 times 30. I broke 30 down as 5 times 6. Then the 6 is 2 times 3. And I need groups of 2. And the only group of 2 that I see are the 5s. So that can come out of the radical as a 5 radical, and what's left over right here will be inside. So this simplified is 5 radical 6. And if you don't believe me, you can check it in your calculator to see that this has the same value as square root of 150. Okay? Now I have the 4th root of 972. So I broke it down. I got 2 times 486. Then I broke 486 down. 2 times 243. 3 times 81. 9 times 9, and then I broke each of those down. So I have, this looks quite long when I break it all down to the basic factors. Okay. So now I have to take out groups of 4. You betcha. So I've got 4 3's that can come out, and that's it for groups, right? So the 3's can come out, so I have 3, 4th root, because that index stays the same, and then what's left over goes in there. 3 times 2 times 2, or 12. So it's 3 fourth roots of 12. Okay? Now for this last one here, let me move back a little bit so you can see it. I actually put some variables in it because this is where everybody kind of gets stuck. So this is the cube root of 16 8 to the 4th b. Now the only thing I broke down was the 16. So I got 2 times 8, then I broke the 8 down, and then I brought the 4 down. So I ended up getting, I have 4 2's going on here, okay? Which I have to find a group of 3, so that's not a problem. I found a group of 3. So my number is good. But the one thing you need to look at is you now have to look at your variables to see if there's any other groups of 3. And I have an a to the 4th here, so I have 3 a's I can take out, but 1 is going to be left behind. So when I go to do this, this is going to be a cube root. What's going to be left in there is just one of the 2's. An a is going to be left in there, and the b is left in there because I couldn't find groups of 3. But one group of a's could come out and one group of 2's. So I have 2a cube roots of 2ab. Okay? Now let's do addition and subtraction. In order to add or subtract radical expressions, it is necessary to have like terms. What are like terms? Well, like terms are like radicals have the same index and the same radicand. So they have to have the same index and radicand. So if you look at here, I have the same index on this problem here because they're both square roots, but the radicand's different. So we have to work on the radicand to get it the same so we can combine them. So I broke these down. I have the square root of 18 and the square root of 50. There's one thing I do want to show you here because some kids will say, Mrs. Pond, right here, can I stop right there? Because I know 9 is a perfect square and that can come out as a 3. Or you could keep going and say, okay, I have 2 groups of 3 that can come out. Either way works as long as that you know what you're doing. So when I go to simplify this one, I have 3 radical 2. Because one group of 3 can come out and a radical 2 is left behind. Okay? This one's the same way with the radical 50. If you get to 25 times 2, you can say, wait a minute, I know 25 is a perfect square. I can pull that out of the radical and make it a 5. That's fine. Or keep going and say, okay, I have 2 5's. I'm going to be adding a 5 radical 2. Now by doing that, I have like terms because my index is the same and my radicand is the same. Now you just combine them. So 3 plus 5 is 8. So my answer is 8 radical 2. All right. Let's look at this one right here. I have the cube root of 81 plus the cube root of 24. I broke it down. And now these, you should probably go all the way, or you can use the factoring. I need 3's. I need 3 3's, so I have it there. So this is actually 3 cube roots of 3 plus this one I have 3 2's, 2 cube roots of 3. And you guessed it, that's going to be 5 cube roots of 3. Okay. Let's practice a couple more just to make sure you have it for your notes. So here I have 2 radical 98 minus 3 radical 32. Now what this means is if I have 2 radical 98, so when you go to simplify this, whenever you take something out of the radical, you have to multiply it by the coefficient in front. So here I have, it's a square root, so I got 2 7's. If I bring the 7 out, that comes out to be 14 radical 2. Okay? Now this one I am subtracting, alright? So this one out here I'm going to subtract, so I do this one, and I say I have 2 4's. The 4's can come out. If they come out, I have to make sure I multiply it by 3. So that's going to be minus 12, and a 2 is left. So I have 14 radical 2 minus 12 radical 2. So my answer to that would be 2 radical 2. Right. And the last one I wanted to show you right here was I have 2 radical 45. I broke it down. I have 3's here. Okay. So 3 times 2 is a 6 radical 5 minus, here I have to have, it's 3 radical 80. I have to have a couple 2's here. And this one right here is going to be, I say, okay, I've got that. And then I'm like, is there any other 2's? Well, I have another 2 here and another 2 here. So actually 4 can come out. So I have 2 times 2 is 4, so I'm at minus 12 radical, and what's left over is a 5. This is the only one left. So this is minus 6 radical 5. Okay?